Something weird is happening with Fu-I Atlas. It's not just another comet. On July 1, 2025, astronomers found an object racing into our solar system that doesn't behave like anything they've ever seen. Officially, it's only the third interstellar visitor ever confirmed, but almost nothing about its motion, its chemistry, or even its emerald glow makes sense. The data say it's from another star. The evidence says it shouldn't exist at all. And with every new observation, the questions pile up. If 3I Atlas isn't what we think, what exactly is moving through our backyard right now? At 3:19 in the morning on July 1, 2025, an alert pinged through the Atlas Survey Control Room in Chile. The system had flagged a faint, fast-moving object against the background of Serpens Cauda, an object that didn't fit any known orbital path. Within minutes, the team downloaded the raw images and ran them through orbital software. The results came back with a single number that changed everything: eccentricity greater than 1. That's the mathematical signature of a hyperbolic orbit, meaning this thing wasn't just passing through. It was coming from outside the solar system, moving so fast that the sun's gravity could never pull it back. The lead astronomer pulled up the Minor Planet Center's submission portal and entered the details: coordinates, timestamps, brightness, motion vectors. The MPC's servers processed the data, and almost instantly, a chain reaction began. Observatory Slack channels lit up. Telegram groups buzzed with the news. Within hours, astronomers across 3 continents were combing through old survey images, racing to find earlier traces. Someone found a faint streak on June 14th, confirming the object's path and speed. The calculations held: eccentricity greater than 1, outbound velocity over 58 kilometers per second. The Atlas team lobbied for the official designation, 3I, the third interstellar object ever confirmed. "We expected dust," the survey lead later said. "Instead, we found something glowing, metallic, and silent." Only 3 times in history have astronomers confirmed an object from another star entering our solar system. The first, in 2017, was Oumuamua, a cigar-shaped mystery that flashed past Earth and left behind more questions than answers. 2 years later came 2I Borisov, which looked and behaved like a classic comet, except for its origin. Now, with 3I Atlas, the count stands at 3. That's the entire list. In a universe filled with planets, stars, and drifting debris, the number of interstellar visitors we've actually spotted is so small it barely registers. Most telescopes scan millions of stars and trace thousands of comets, but nearly all of them belong to our own solar system. The odds of catching a true interstellar object, let alone one with unusual chemistry and behavior, are almost vanishingly low. This rarity isn't just a quirk of observation. Each new find rewrites the boundaries of what's possible. Oumuamua challenged our models by accelerating without a visible tail. Borisov was the first interstellar comet to show a coma and tail, but its chemistry still set it apart from local comets. With 3I Atlas, astronomers realized they were racing against time. Every new data point could reveal something never seen before, or it could slip away forever. The urgency to observe, measure, and understand grows sharper with each discovery, because these moments are not just rare, they might never repeat in a human lifetime. But the story of 3I/Atlas didn't just unfold in the hands of professionals. Word of the discovery spread quickly, and soon a cluster of amateur astronomers in southern Africa decided to try their luck. They timed their telescopes for the lunar eclipse in March 2026, a night when the sky would be at its darkest, the moon's shadow blotting out all but the most persistent lights. That's when the first truly strange images started to appear in astronomy forums. There, right in the heart of the frame, was a comet glowing an almost electric green. Not a faint haze, not a washed-out blur, but a sharp, vivid emerald streak burning through the blackness. People double-checked their camera calibrations and swapped raw files to see if it was an artifact. It wasn't. The color was real, and it was unlike anything they'd expected from a comet supposedly made of dust and ice. In a single night, 3I/Atlas shifted from a line of orbital data to a living, visible enigma, one that anyone with a camera and a clear sky could witness for themselves. Now, the real surprise came when the world's biggest telescopes got their first look at the chemistry of 3I/Atlas. The James Webb Space Telescope, the VLT in Chile, and Gemini North all pointed their spectrographs at this new arrival and started picking apart the light. What they found was almost impossible to reconcile with any comet seen before. The coma, the cloud of gas and dust around the nucleus, was not just bright, it was absolutely dominated by carbon dioxide. That's already strange, since most comets in our solar system have way more water than CO2. But in this case, the water vapor was barely detectable. Even more confusing, the usual signature of diatomic carbon, the stuff that turns comets green, was missing. The green glow was there, but the chemical responsible for that glow was not. Instead, the spectra showed clear lines from metallic nickel, and at distances where nickel shouldn't be vaporizing at all. Iron, which usually appears alongside nickel in comet outgassing, was almost absent until the comet got much closer to the Sun. Teams checked and rechecked their calibration logs, but the data held up. Every new observation seemed to break another rule. The deeper astronomers looked, the less sense the chemistry made. But there's another layer to the mystery, and it's not about what 3I/Atlas is made of, it's about how it moves. Most comets wander, pushed around by jets of vapor as sunlight boils away their ices. This outgassing acts like tiny thrusters, nudging their paths day by day. When orbital analysts at JPL ran the numbers for 3I/Atlas, they expected to see the usual zigzags, random, unpredictable, a little messy. Instead, the data showed something else entirely. The non-gravitational acceleration, which measures these jet-driven wobbles, came out to just 1.5 kilometers per day. That's not just low, it's almost flatlining. For comparison, 2I/Borisov, the last interstellar comet, drifted by more than 100 kilometers per day. Hale-Bopp, one of the biggest and brightest in living memory, still shifted about 10 kilometers daily. Oumuamua, the original wildcard, changed course by over 1,000 kilometers every day it was tracked. But Atlas, it's barely budging. One JPL orbit analyst put it this way: "It moves with machine-like precision. That's not how comets behave." The numbers are clear. 3I/Atlas isn't just weird in its chemistry. Its path through the solar system is so steady, so unbothered by the usual forces that it almost looks programmed. And that's the kind of evidence that keeps astronomers up at night, wondering what could possibly explain it. Now, when astronomers first laid out the numbers on 3I/Atlas, the debate started almost immediately. Chemists pointed to the missing diatomic carbon and suggested that maybe some exotic carbon compounds, stuff we've never seen in a comet, could be faking the green glow. If that's true, it would mean Atlas is carrying a chemistry set from another star system, with molecules that don't exist in our own backyard. Solar physicists, on the other hand, started looking at the solar wind. They proposed that maybe the unique mix of gases in Atlas's coma is getting zapped by charged particles in a way that only happens when you mix the right elements at the right distance from the Sun. That could explain the nickel vapor and the weird color, at least in theory. Then, in the far corner, there's the idea that won't die, artificial activity. A handful of SETI folks and engineers have pointed out that the steady trajectory and the specific blend of CO2 and nickel could look a lot like exhaust from a controlled propulsion system. No one has evidence for that, but the numbers are strange enough that the question keeps coming up. The reality is every group is working with limited data. The spectrographs are noisy, the window for observation is short, and no one has a complete picture yet. So for now, all three ideas are still on the table, each with its own gaps and possibilities. Have you ever heard of the WOW signal? Back in August 1977, a radio telescope in Ohio picked up a 72-second burst at the hydrogen line, so unexpected that the astronomer on duty circled the printout and scribbled "WOW" in the margin. That signal came from deep in Sagittarius, a patch of sky thick with stars and cosmic noise. Decades later, when astronomers mapped the incoming path of 3I/Atlas, they realized it cuts through nearly the same region. Not an exact match, about 8.5 degrees apart, but close enough to make people pause. The overlap isn't proof of anything. Sagittarius is vast, and the sky is full of coincidences. Still, when the old Big Ear team saw the vector maps cross, one of them described it as a goosebump moment. As one SETI researcher put it, "If this is just a rock, it's a very weird rock." On July 1st, 2025, 3I/Atlas became only the third confirmed interstellar object, documented through MPC reports and JPL orbital calculations. Unlike any comet observed before, it displayed a persistent green glow without the usual carbon signatures and released metallic vapors, as confirmed by VLT and Gemini spectra. Its trajectory, measured at a steady 1.5 kilometers per day, non-gravitational shift, stands in stark contrast to both Borisov and Oumuamua. Despite these well-documented anomalies, no natural explanation fully accounts for the combination of color, chemistry, and motion. The coincidence of 3I/Atlas's inbound path with the region of the 1977 WOW signal is noted in archival sky maps, but evidence remains inconclusive. With key data windows still open and questions about its origin unresolved, the scientific record shows how much remains unknown about interstellar visitors. As more observations are planned for December, the case of 3I/Atlas is a reminder. Even with today's technology, the universe continues to present mysteries that challenge what we think we know.